Hello friend, in today's video we will learn very interesting and amazing project. In this project we will control the virtual hardware from the Protis software like bulb, DC motor, buzzer, LED through our actual mobile application. So this is a very interesting project, and in this video we will learn how to build this project, what is the programming part of this project, how to design this type of hardware, and later we will see how to run this project. So I request you please watch this complete video so that you will get idea about each and everything about this project. Okay, so first we will see the final output of this project, so that you will get idea about what you will learn from this video. So let's start this project. So you can see when I run the project on the LCD, you can see different types of we have a motor, we have buzzer, we have bulb and LED also. And the status of the buzzer LED, that is different devices print on the L3. So currently LCD, all the devices are off because I have given the off signal from my mobile application. So now I will open the mobile application. So now I will open the mobile application, and through the mobile application I will control the virtual hardware. So for mobile application I will use MQTT Pro dashboard, and in this mobile application you can see LED on, different types of buttons are there. So if let's say if I want to turn on the LED, just I click on this LED on. So once I click on the LED on button, you can see LED also turn on at this side, and the LED on status also print on the LCD. Let's say if I want to turn on the bulb, AC bulb, so through the relay, so I will click on the bulb on button from my mobile application. So once I click on the bulb on button from my mobile application, you can see this is the application, and bulb on button, bulb on message also print on here, and the bulb also turn on. Let's say if I want to turn on the motor in the clockwise direction, so I will click on the motor clockwise button on my mobile application. So once I click on the motor, start rotating in the clockwise direction. And let's say if I want to stop the motor from the mobile application, I will click on the motor stop button. So once I click on motor stop, you can see motor also stop here, but motor also stop on the LCD, that is message present on the LCD. Let's say if I want to turn on the buzzer, so I will click on the buzzer on button from my mobile application. From my laptop, and if I want to turn off the buzzer, just click on the buzzer off button from my mobile application. And if I want to turn off the LED, just click on the LED off button from my mobile application, and you can see on the Protis the actual LED will be turned on. So this is the Protis simulation for this project, and definitely you will learn many things about from this project. So I request you please watch this complete video so that you will get idea about each and everything about this project. Okay, before start the next part, I request you please subscribe my channel. Currently you can see I have 1102 subscriber and the 2604 watch hour, but to verify my channel on the YouTube I require 4000 watch hour and 1000 subscriber. So with your support, thanks for support. Already I have completed 1000 subscriber limit, but the 4000 watch hour limit is still there. So please watch my all the video, please support me. Also you can see once you click on the subscribe button, it is also beneficial for you because you will learn many project from me with a free. I haven't taken any charges for any project. Just watch my all the video and you will improve your knowledge. And you can see I have uploaded more than 54 video on the YouTube. So please watch each and every video so that I can complete my YouTube criteria to verify my channel. Thanks for support. Now to execute this project, you require the Protis 8.9 software in your laptop. If you don't download, if you don't have the Protis 8.9 software in your laptop, just go to the YouTube and search free Protis 8.9 software. You will find many video, and from that video you can download the Protis 8.9 software. So once you download the Protis 8.9 software, just right click on this software and go to the run as administrator. Click on this button. Now we will see how we can create the Protis software, Protis circuit in the Protis 8.9. So if you want to create a new project, go to the new project, and here you can give your project name here, then path you want to where you want to save this project, then click on next button. Then click on next button. Before that, select this create schematic. Click on next button. Select this do not create a PCB layout. Click on next button. Then go to the create firmware project. Select family. Then go to the Raspberry Pi and click on next. Click on finish. So once you click on finish, you will find two windows, schematic capture and source code. In the source code window, we will write our code, and the schematic capture you have to design the circuit by following my video one by one. So first part is we will create a circuit for LCD module. So go to the component mode, click on P and type here LCD 16 cross 4. We will take 16 cross 4 LCD for this project, and click on OK and click on place that LCD here. After that, you have to first connect all the default pin to the input pin of LCD. So first go to the terminal mode, then click on ground and connect the ground to RW pin. So connect here this ground. Now click on again terminal mode and click on default. After that, select default pin, right click on the default pin, rotate one anti-clockwise. After that, place that pin here. After that, copy this pin, copy to clipboard, right click, paste from clipboard, paste here, and copy to clipboard, paste here in front of D4, copy, paste in front of D5, copy, paste in front of D6, copy, paste in front of D7. After that, connect pin one by one. Okay, now next part is you have to connect RS pin to the GPIO 4. So double click on this RS default pin and give here name GPIO 4. Then after that, enable pin should be connected to GPIO 17 of Raspberry Pi. So double click on enable pin and give here name GPIO 17. After that, D4 pin should be connected to GPIO 18. So double click here and give here name GPIO 18. Click on OK. Now D5 should be connected to GPIO 27. So double click on D5 pin and give your name GPIO 27. Then T6 should be connected to GPIO 22. So double click here and give your name GPIO 22. Then D7 should be connected to GPIO 23. So double click here and give your name GPIO 23. Click on OK. After we complete the LCD part, next part is we have to connect the AC bulb through the relay module. So if you want to take the relay module, go to the just this component mode, then click on P and type here relay. So once you type here, you have to select this animated relay and go click on OK button and place that relay here. Then after that, you have to double click on this relay and give here voltage 5 volt, because our relay will work on the 5 volt, so that give here 5 volt. Then you require the AC bulb, so that again go to the component mode, then click on P and type here bulb. So once you type bulb, you can see lamp. You have to select animated light bulb, then click on OK and place that bulb here. So one part of bulb should be connected to this point, and the next part of bulb should be connected to a 230 volt. So where you find the 230 volt AC supply, just go to generated mode, then click on sign and place that sign supply here. Connect that sign supply here to next part of bulb. Double click on this sign supply and give your voltage 230 volt and click on OK. Then next part of relay, this part of relay should be connected to ground, so that this circuit will be completed once the relay turn on, and then our bulb will turn on. So go to the terminal mode and click on ground and place that ground here and connect that ground to here. So this is the one part. Now next part is we have 2 points at the output side of relay. So one point should be connected to the Raspberry Pi and next point should be connected to ground. So if you want to take the ground, just go to the terminal mode, click on ground and place the ground here and connect that ground here. Then next part is you have to give the this pin should be connected to Raspberry Pi pin GPIO 5. So how to connect this one? Just go to the component mode, terminal mode, then click on default pin, place that default pin here, connect that default pin here to here and double click on this pin and give your name GPIO 5 and click on OK. Now next module we have to connect is L293, that is DC motor. So how to connect DC motor? You require L293D IC. So where from you select this L293D IC, just go to the component mode, then click on P and type here L293D. So once you type L293D, just click on this IC, click on OK button and place that IC here. Then after that, first connect the VCC pin of this IC to 12 volt DC supply. So go to the again generated mode, then click on DC supply and place that supply here. Then connect that supply one by one to this pin, connect that supply one by one to this pin. So double click on this supply and give your voltage 12 and click on OK. Then after that, click on you have to connect the ground to ground. Just go to the again the terminal mode and click on ground and place that ground here. and connect that ground to here. Then at the output side you require the DC motor, so that take the DC motor from the component mode again. Just go to component mode, then click on P and type here DC motor. So once you type DC motor, select simple DC motor and click on OK and place that motor here. So one pin of DC motor should be connected at this point. Second pin of this DC motor should be connected at this point. Then after that enable pin should be connected to 12 volt again. So how to connect? You have to take the default pin again and connect that default pin to enable. Second default pin should be here and connect that pin to this 12 volt. Double click on this pin and give your name EN. Double click on this pin, give your name EN. So virtually these two pin get shorted and this pin get connected with the 12 volt. Now next part is IN1 and IN2 should be connected to Raspberry Pi. So how to connect? Just go to terminal mode, then click on default and place two default pin one by one here. Then after that connect this pin to here, second pin to here. Then first pin should be connected to GPIO 6 pin of Raspberry Pi and second to GPIO 12 pin. So how to connect? Just double click on this pin and give your name GPIO 6. Click on OK and give your name GPIO 12 and click on OK. Now the next part is we have to connect the LED module with our Raspberry Pi. So how to take the LED module? Again the same method. Go to the component mode, then click on P and type here red LED. So once you type red LED, click on this LED and click on place here. So one by one you have to paste 3 LED at a time. So once you paste the LED, just arrange the LED in the line. Then after that all the positive pin of LED should be connected to Raspberry Pi pin. So take the common pin first. So this one is common and negative part of LED should be connected to ground. So again take the common pin at the negative part. Take the ground first, go to the terminal mode, then click on ground button and place that ground here. Connect that ground to here. Again go to terminal mode, click on default pin so that we can connect the positive pin with the Raspberry Pi. So this pin should be connected to Raspberry Pi 30 number pin. So double click on this pin and give your name GPIO 13. So in this way we have completed the LCD, then DC motor, then relay, bulb and the LED. Now next part is buzzer. So how to connect the buzzer? Again the same method, you require NPN transistor. So go to the component mode, click on P and type here NPN. And once you type NPN, just select this NPN transistor, click on OK and place that transistor here. Then first part, this part of NPN transistor should be connected to ground. So where you want to select the ground, just go to terminal mode and click on ground and place the ground here. And double click on this. Then you require the buzzer. So go to the component mode, then click on P and type here buzzer. So once you type buzzer, click on this DC operated buzzer and click on OK and place that buzzer here. So one part of buzzer should be connected to NPN transistor, this part, and next part of buzzer should be connected to VCC. So go to generated mode, then click on DC supply, place the DC supply here, connect the DC supply to here, double click on this DC supply and give your voltage 5. Then double click on this buzzer, give operating voltage as a 5 and click on OK. Now this part of transistor should be connected to Raspberry Pi pin. So how to connect? Again the same method. Just go to the terminal mode, then click on default pin, place the default pin here and connect that default pin to here, and this pin should be connected to GPIO 16 pin. So GPIO 16 and click on OK. So in this way we have completed all the circuit diagram with this required to this project. Now please arrange the circuit diagram like this. I have arranged here. It's look like very neatly and clean also. So arrange like this one, and if you want to download this simulation ready-made, just go to the Google Drive link given in the description, download the ready-made simulation from there, and you can find this diagram ready-madely available at your laptop. So in this way we have completed the circuit diagram. Now we will see the importance of each and every line from the source code. Now we will see the importance of each and every line from the source code. So first line is import time. So if you want to require some delay in your code, if you want to add that delay in your code, you require this time library. Next line is import Raspberry Pi.GPIO. So if you want to access any GPIO pin from the Raspberry Pi, then you require the GPIO library. Then import OS system. We will see this library later. What is important of this library later. The next library is very important, PAHO and URL pers. Then how to install this library in the Protis software, that I have already explained in my car parking system. So I will provide the linking of this video in the description of our current video. So go to the car parking system project and watch this video, and at least from this video watch how to install the software part. So in that video I have explained you how to install the URL pers and PAHO client in your laptop for Protis software, and then only this project will work. Otherwise you will get many errors like doesn't found the power library or doesn't found the URL pers library in the Protis software. So again I will repeat you how to install this two library. I have already explained in my car parking system project. The link is given in the description. Please watch this video before start this control device through mobile application video. Okay, so next part is once the library installed, next part is GPIO.setup, GPIO board. So basically if you want to access the Raspberry Pi as a complete board, then you require this GPIO.setup method as a board. Then GPIO.set warning to the false. So whenever you require, whenever you use any pin from the Raspberry Pi, then at the starting Raspberry Pi gives you warning that whatever the pin you have used is already used before. To avoid that warning, we will use this line. Then some variable import pulse, import delay. We will see importance of this variable later. Then LCD pin to the 7. So this is very important. Now focus here. So LCD RS pin to the 7. So go to the schematic capture. You can see LCD RS pin is connected to GPIO4, and GPIO4 is nothing but the 7 number pin of Raspberry Pi. So we have defined the pin number of each and every module here. So enable pin also connected to 11. So you can see LCD enable pin GPIO 17 and GPIO 17 also connected to 11 number. So that we have defined, I have defined here LCD enable to 11. With the same logic, I have defined all the pin here one by one for bulb, motor, then LED, then buzzer, all the pin here with the same logic. I hope you understand that. Then next part is we have to define that pin as an input or output. So Raspberry Pi basically send the signal to all the device so that the whatever the pin we will use in this project as a work as a output pin. So to define any pin as an input or define any pin as an output, then we will use this logic GPIO.setup, then pin name, then GPIO.out in case of it is output pin, and in case of it is input, then GPIO.in. So whatever the pin we use for this project is completely output pin. So that we have defined here all the pin as a output pin with the GPIO.setup function. Then after that LCD width to 16, because we have 16 column LCD. Then we have some character variable. We will see importance of this variable later. Then the importance of this variable also we will see later. Then next part is def on connect. So def on connect is basically function whenever your Protis software gets connected with the MQTT broker software, then this function automatically gets called. And after that save.subscribe. So MQTT basically work on the message, token and subscription method. So basically it has a token and token has a message. So in our case our token is LED. So whatever the message coming from the mobile application is with respect to this LED token. So to subscribe that token means to subscribe that message, we require this line self.subscribe. So once we subscribe LED, then whatever the message with respect to the LED token that we will receive on this def on message function. So inside def on message, once we press the button, then token send the message with respect to our button. So whatever the message coming from the mobile application is stored into this message.payload variable. And let's say if you press the LED on button, then our message is LED on sending from our mobile application to this Protis software. Now here we have compare message.payload is equal to LED on or not. So B is nothing but is byte type. So that I have added here B in front of this message. So once the message.payload is equal to LED on, and we will define same message in the mobile application. So at the end we will see how to design the mobile application with this message later part, that is the later part. So once the LED on button is pressed, then message.payload is equal to LED on. Yes, it is LED on. Then we have to print the LED on the LCD. So how to print that one? Just print LCD string, then message LED on line number 1. That's it. Then after that we have to turn on the LED. So how to turn on the LED? You have to send the one signal on the LED. So how to send the one signal? GPIO.output function with LED pin number and GPIO.high. So in this way we will turn on the LED. Now if you want to switch off the LED, how will you switch off? You will press the switch off button from the mobile application, and once you press the switch off button, then LED off message will be sent from with the LED token, and here we will compare the message is equal to LED off. Yes, it is LED off. Then we have to turn off the LED. So how to turn off the LED? GPIO.output LED pin, we have to send the low signal on the mobile on the LED. So GPIO.output GPIO.low, and LED will turn off. So in this way we will turn on and turn off the LED. Next part is bulb on and bulb off. With the same logic, we just whenever you press the bulb on button from the mobile application, bulb on message will be sent here. Then you have to turn on the relay. So how to turn on the relay? Just send the high signal on the bulb relay pin. Then you have to turn off the relay. Just send the low signal on the relay pin. So with this two logic, we will turn on and turn off the relay. Next part is motor clockwise, motor anti-clockwise. So once you press the motor clockwise button, you have to send the one signal on one pin of this motor here and 0 pin at this point. So 1 and 0. So how to send 1 and 0? I already told you. GPIO.output DC motor pin number 1 to high, GPIO.output DC motor pin number to the low. So in this way we will rotating the motor in clockwise direction. So let's say if you want to rotate the motor in anti-clockwise direction, so you will press the anti-clockwise button on the application, then message will be print on the LCD. Then reverse the logic. Motor 1 should get the low value, motor 2 get the high value. So in this way motor will be turned anti-clockwise. Let's say you have to stop the motor. So how to stop the motor? Stop button you will press on the mobile application. Here it will send receive the message motor stop, and then here you can say low signal. So low signal means motor will be stopped at the runtime. So this is the way. Now to turn on the buzzer, same logic. You have to send the 1 signal and 0 signal, same the logic. This is not required in our project on subscribe. So basically whenever you say here self.subscribe, automatically this function will be called and our topic will be subscribe, and this is the way this function will be called. Now next is power.client is equal to MQTT. So whenever you want to access any program from access any function for MQTT, then in that case you require the MQTT variable. So we define here variable here, then we define all the message of MQTT here, then we define the broker name and port name here by using URL string function, and MQTT.connect function is basically used to connect our broker with our MQTT web server and with the port address. So this three line basically you have to connect your Protis software with MQTT web server or with mobile application. One is LCD init function. In LCD init function we have to send some command so that our LCD gets work. So this command thing but start the LCD, take the initial to first row only, message should be printed on first row only. All this command you can see, all this command, and you will see you will get details of this command on Google. You can search the LCD command, you can easily find the importance of each and every command. So main important part of this is how to send this LCD command from Raspberry Pi on your LCD. So there is function lcd.byte, then you have to pass the command and LCD command. So the LCD command is nothing but the variable we have declared already here, LCD command to the false. So we will see this what is this function. So LCD command, it is jump to this LCD byte, then after that here is select GPIO.output LCD RS pin mode. So what is mode? We have sent here mode as a LCD command, so means this is the command mode. So whenever there is a command mode, you have to select RS pin, and that RS pin should be Raspberry Pi should send the 0 signal on that RS pin. So you can see LCD command mode, this is variable, and this variable has a value false. So whenever you are sending the command on LCD, you have to send RS to 0, that is RS 0 signal on RS pin. So that we have already created function LCD byte send command, and LCD command, this is nothing but 0 automatically send on RS pin with this function GPIO.output LCD RS to 0. Then after that we have to send the data. So data is nothing but this is a 8 byte of data. You can see this is 8 byte of data, but in our schematic we use the 4 byte pins, 4 pin. So we have to segregate our data into 4 byte. so that we use another logic. So once this signal 33 number sent to LCD byte, it comes here. Then first part is set the command as a command mode. Then GPIO dot output, all these our 4 pins should be selected to false by default. D4, D5, D6, D7 should be the false. This means that the 0 signal sent on the LCD D4, D4, D5, D6, D7 by default. Then next line is if bits ending with 0, 1, 0, that is higher byte is equal to 1, 0. So let's say this is 33 number. So first we have to send the 33 number, 33 data or command on LCD. So in 33 we have to first aggregate the higher byte first and then lower byte first. So you can see this is our higher bytes and this is our lower byte. So from the higher byte we have to send the D4 first. So to send the D4 byte first, we have to masking with 1, 0. So after masking with 1, 0, you can see the D4 bits get one value. So if that value is 1, then we have to send one signal on D4. So that 1 again shifted to the D5, then again masking with 2, 0, and if the value is 2, 0, then we have to send the one signal on fifth number of LCD bit. So this logic applied to each and every pin D6 and D7. So once this higher bits get executed sent on LCD, we have to shift the same logic to the lower bits. So again lower bits we have to send D4 first, then D5, D6 and D7. But in that case the masking is 0 cross 0, 1. So we will see the code. So first we are sending 33, then the LCD bytes get here, then 33 mode is command because we are sending command, then GPIO dot output LCD RS pin to the mode, that is mode is command, that is 0. That means 0 signal sent on the RS pin. Then by default we have to send the 0 signal on each and every pin D4, D5, D6, D7. After that we are checking is first bit masking with 1, 0 is equal to 1, 0. If 1, 0, then we have to send D4 to the true. If that is not equal to 1, 0, then we have to already send false signal from here. Then second bytes from the higher bits 2, 0. If this value is 2, 0 after masking, then we have to send D5 to true. Then third byte 4, 0, then D6 to true, and then last byte D7 byte. If we are masking is 8, 0, then we have to send D7 to true. If any of this condition false, then we already send the false signal. So once you send the higher signal, you have to toggle the enable pin. So to toggle the enable pin, we are using this logic LCD toggle enable. So in that logic, we have to pass the high-low signal on the enable pin. So to pass the high-low signal, this is the logic time.sleep. First we are sending some delay, then GPIO.output enable pin to a true. So it will send the high signal on enable pin, then time.sleep to the pulse, then it is sending some time sleep, then GPIO.output LCD enable pin to a false, it is sending the 0 signal on LCD enable pin, then after some delay, so it will toggle the pin. So once you send the higher bits, we have to send the lower bits again. So same logic will apply. First we have to send the 0 signal on each and every pins D4, D5, D6, then again masking with 0, 1. So in this case is 0, 1. We are first masking with 1, 0 because it's higher bit, and this is the lower bit because this is lower bit, we have to send 0, 1. So if the value is 0, 1, then we have to send LCD D4 pin to the true value. Same for the D5, D6, D7. So in this case we are sending the data on LCD pin. After sending the data lower bits, we have to again toggle the pin with a toggle function. So this is the basic idea behind how to send the data on LCD. So once LCD get initialized, the next part is we have to send the welcome function, welcome message on LCD line number 1. So we have already defined LCD line number 1 variable, which is nothing but the 0 value. So LCD.string welcome. So welcome is nothing but the array. So each array is divided into again 1 byte with their index. So index 0 contain W, index 1 contain E, L contain second index, then C. So this iteration we will do by the for loop. So first go to the LCD string function. So inside LCD string function there is a message that is welcome and line is line number 1. So first we have to calculate the width of that message with this function. So once you calculate the width, we have to tell LCD that this message has to print on line number 1 by using this command, line command. So line come and get execute with LCD byte. Same logic will execute. Then next is we have to iterate the welcome message. To iterate the welcome message, we will use for loop for I in the range of LCD width. So I is not starting with 0 and it incrementing 1 2 3 4 till LCD width. What will be the length of this message? So let's say first I is equal to 0. So LCD byte function get execute with parameter message of I. So I is 0, then message of I is 0, nothing but the W. Then LCD character. Then we are passing the character to the LCD byte. So that LCD is so that RS pin set to 1, and then our message get print. Once the W is sent on the LCD, you have to send the E. So I increment to 1, then E will send, and same with the same logic, all the message send on the LCD. So okay, once after the welcome message printed, you have to print LED all the op message for the for our device. So with this line, then delay, then while one, MQT loop function, basically it is activating the Protis software for connecting the Protis software for infinite number of time with this line, and then sleep. So this is the basic idea behind this code. Now we will see how we can design the mobile application. So now first we see how to create the mobile application to send the data from Raspberry Pi on the mobile. So first you need to go to the Play Store. So type Play Store. Then after you type Play Store, go to the search MQTT dashboard application. So once you search MQTT dashboard application, you can see this MQTT IoT and Node-RED controller dashboard application you should open. Then after that you should install that application. So once you install that application, open that application. So once you open that application, you can see this window will open, and first we need to add the broker for our project. So if you want to add the broker, just click on the add first broker. Then after that you should give the broker name here. So in that case my broker name is let's say Rahul. Then you should give the broker address. So broker address is starting with TCP double dot and then slash. So in code you can see we already given the broker address on the line URL string OS environment get, then TCP broker EMQX.io. So type as it is that line here. So first type TCP, then double dot, then /2 times, then broker, then dot EMQX, then dot IO. So this is your broker name. After that you have to provide the port name. The port number is 1883. That also we have given in our code. After that click on save button. So once you click on save button, this broker will be start connecting, and once they start connecting, it will show broker is connected and there is nothing. Now before start the adding any button, make sure the internet is connected. Then click on this plus button, then go to the button. So once you go to the button, give the button name here. The first button is LED on. So LED on. Then publish topic. The topic name is our LED that is defined in the code, and the payload is the actual message that you have to send after you press the button. So message is LED small underscore capital on. So and they go to the question mark, then select the icon that is LED, search, select this LED, give the green color for this LED and click on OK and click on OK. Now you can see we have created this. Then duplicate the message again, this one, duplicate this button, then go to this button, edit, then give here name LED off. Publish topic should be same LED, and payload that is actual message you have to send is LED off, off capital OFF. Then go to this icon and select the red color for off button and click on OK. Now we have created two buttons. Now for the same you have to create the button for bulb on and bulb off. So duplicate this on button again here and go to the edit, then give your name bulb on and topic should be the bulb on. Publish topic should be LED and payload should be bulb on. Then change the icon. So give your icon bulb, click on OK, click finish. Then after with the same logic, bulb off, duplicate this one and go to this edit and give your name bulb off, payload should be the bulb off, and this message should be typed very carefully. It is with respect to code only, otherwise your hardware will not turn on and turn off. So bulb off, and click on OK again. So we have created 4 buttons. Now next part is for motor we have to create, for buzzer we have to create the button. So again duplicate this message, duplicate this button, go to edit and give your name buzzer on. Then topic should be same and the message should be buzzer on. So buzzer is B small buzzer and on should be capital as per the code. And click on this and change the icon here. You can give the bell icon here, bell, click on this bell. Okay, save. Then same duplicate this topic again, and here topic should be buzzer off, then here should be buzzer off, payload. Then change the icon, change the color, then icon, bell, this one, click on OK, click on OK. We have completed the for buzzer, LED and the bulb. Now next part is we have to create for the motor clockwise, anti-clockwise. So same again duplicate here, go to edit and give your name motor and clockwise, motor clockwise. Then LED is topic and the message should be as per the code motor underscore clock. So I will type here message motor underscore clock, and then you can change the motor icon here. So I will give fan here icon, then fan, this one, click on OK, click on OK. Now this one is created. With the same duplicate this one, motor anti-clockwise, give the name here motor anti-clockwise. Then payload should be motor anti as per the code. So motor anti, and change the color, click on OK, click on OK. Now third button is duplicate again and stop, motor stop. So should be edit, give the name here stop, and payload should be motor stop as per code. So code is as per code, this one motor stop, and change the color as per you want, click on OK and place OK. So in this way we have created the app successfully. Now we will check app will work or not with our project. Now we will see how to run this project. For that you have to open the Protis with administrator permission. So right click on Protis, Protis 8.9 should be software you require, then run as administrator, then click on use button, then after that open project. And I hope you downloaded my project from Google Drive link. So go to that downloaded folder. So I will check this one, and you should open this control device through mobile application Protis project and click on open. Once you open the this simulation, you will find ready-made simulation. Just click on after you open the Protis software, just click on this button. Okay, now I will open my mobile application. Okay, now I have opened my mobile application. You can see current status is LED off. Now I will turn on the LED. Just click on the LED on button. So you can see LED is turning on with my mobile application. Then bulb on again. Then motor should be on clockwise direction. Okay, so app will be work successfully. Now in this way you can run your project successfully. Thank you for watching.